All right, good morning, class. Happy Monday. Here we have a right triangle with a hypotenuse of 3. Now, I don't know what either of these two legs is. I don't know what x is. I don't know what y is. But there is one relationship that I can say for absolutely certain because it's the same relationship that exists for all right triangles. Take a moment and see if you can figure out what I'm talking about. There is a relationship between these three sides that we can write down, even though we don't know what the two legs are. So even though we don't know what x and y are, we do know from the Pythagorean theorem that x squared plus y squared equals the hypotenuse 3 squared. So we could also say x squared plus y squared equals 9, which is 3 squared. Both of those are totally fine. Now, why am I talking about right triangles when we are in a unit about circles? Well, what if we were to take this right triangle and made the hypotenuse the radius of a circle? Now, let's remember the actual definition of a circle. Remember that the definition of a circle mathematically is all points that are one set radius from the center, which means that if I were to choose another line, another point out on the edge of the circle, that radius would also be 3. Okay? And just like with the other one, we can take that other point on the circle and we can make a right triangle out of it with its own x and y. I'm labeling them x2 and y2 because they are clearly not the same as the x and y from the first triangle, but the fact remains that the x value squared plus the y value squared still equals 3 squared. Because again, even though we are looking at a different point on the circle, the hypotenuse is still 3, so no matter what those two legs are, they will still follow the Pythagorean theorem. And that's true no matter which point on the edge of the circle you're talking about. Everywhere on this circle will have this same x squared plus y squared equals 3 squared relationship because it's all just a bunch of right triangles. So from this, we can derive, using the Pythagorean theorem, the equation for any circle of any radius centered at 0, 0. That's kind of the important bit. So the equation of any circle that has its center at 0, 0 at the origin is x squared plus y squared equals radius squared. And that's where the equation of a circle comes from. It's, again, nothing mysterious. It's nothing arcane. We just took the Pythagorean theorem, also known as the distance formula, and we generalized it to an entire circle instead of one specific point. Now, no matter what x and y are, we know that they have this relationship with the radius, and we can use that to make a graph. So let's do a couple of examples. So example 1, what is the equation for this circle right here? Now, this circle, pretty clearly, is centered at 0, 0, and it looks like it has a radius of 1, 2, 3, 4, 5. So take a moment, pause the video, see if you can give me an equation for this circle. Ready, set, go. Well, okay. We know from the notes we just took that the equation of any circle at the origin that has its center at the origin is x squared plus y squared equals r squared. Now we're not looking for numbers for x and y because x and y can be any combination that gets you to the edge of the circle, but we do know that the radius is 5, so the correct answer to this problem is x squared plus y squared equals 5 squared, or 25. That is absolutely an acceptable way of writing this. And again, if you don't believe me, jump over to Desmos on your own, open the graphing calculator, and type in x squared plus y squared equals 25, and see what happens. So that's example 1. Let's do another one. Okay, in our second example, you'll notice that we don't have a picture. We're just told that the center is at 0, 0, and that the radius is 121 inches. Now, be careful here. The radius is 121 inches, not r squared. So, once again, we know from previous notes that the equation of any circle that is centered at 0, 0 is x squared plus y squared equals r squared. And in this case, that means x squared plus y squared equals 121 squared. If you were thinking about 11, that means you were going the wrong direction. You took the square root instead of squaring it. And again, you can go ahead and square out 121 and get a very large number, and that would also be a correct answer, but I'm not going to bother. Let's do one more example of this, and then we'll move on. In example 3, we still have a circle that is centered at the origin, but we don't know what its radius is. We only know that one of the points on the edge of the circle is -3, 4. So we already know that the x squared plus y squared part is going to stay the same because this is centered at the origin, but we need to know what's the radius. Once we know the radius, we can write this out. Well, okay, the radius is right here, right? And once again, as we've been doing this whole video, we can make that into a right triangle. And we know that the x value here is -3, and the y value is +4. Because again, the x value is left and right, and the y value is up and down. So if we know where that point is, we know the two legs of this right triangle. Now, I know you may be thinking, wait a second, you can't have a leg that's -3 because you can't have a negative distance, but it's still okay because when we go to do the Pythagorean theorem, we will end up squaring it, making it positive. So yes, you are allowed to have -3 on this circle. Okay, well, let's find out. What's the radius? We know that the radius squared is going to equal x squared plus y squared. Again, it's just the Pythagorean theorem, and once we have the radius, we can generalize. Okay, so -3 times -3 is +9. 4 squared is 16. So we get r squared equals, let's see, 16 and 9 is 25. So we get r squared equals 25, which means that our radius is 5. Now, funny story, I actually, for the purposes of this problem, I did not have to find the actual radius. I don't need to know what r is, I just need to know what r squared is, right? Because our equation is x squared plus y squared equals r squared. Once I know r squared, I can just stop. There's no need to take the square root and do that extra work to find out what the radius is when all I'm interested in is the equation of the circle. If I ask you what the radius is, then sure, you might want to take the square root, but save yourself that extra step. Once you have r squared, you can go ahead and write out your equation. And that equation, in this case, is x squared plus y squared equals 5 squared, which is 25. So that's the general idea behind the equation of a circle. It's just the Pythagorean theorem, except set up at every single point on the circle simultaneously. Now things do start to get a little bit more complicated when you move the circle around so that the center isn't at 0, 0, but we're going to go ahead and do that in the next video. So for now, thank you very much for watching. I hope you're having a great day. I hope you're having an okay quarantine, and class dismissed. See you next time.